All right, let's dive in. We're about to go on a pretty wild journey. Not across mountains or anything, but deep inside the software that powers, well, pretty much everything you do online. We're talking about the Database Management System, or DBMS for short.
Think about it for a second. You search for something, you hit enter, and bam, the answer is right there. It honestly feels like magic. But behind that split-second magic is this complex, incredibly fast machine. And for most of us, what's happening in there is a total black box.
So that's what we're going to do right now. We are prying open that black box. We're not just going to look at the data itself, but at the actual software, the cogs and wheels, if you will, that make the whole thing work. Let's get into it.
Okay, first things first. To get a database to do anything, you've got to speak its language. And as it turns out, it's basically bilingual. It understands two very different kinds of commands. And this split is really, really important. On one side, you have DML, which is all about working with the data that's already there. Inserting new stuff, changing it, or just grabbing it. On the other side, you have DDL, which actually defines the container. It creates the tables and the structures that hold all that data. It's really the difference between doing stuff and building the place where you do the stuff. So when you send one of those doing commands, like a select query, the very first component it hits is the DML precompiler. The best way to think of this is as a translator. It takes your request, which is kinda human readable, and turns it into low-level code that the rest of the system can actually execute. But if you send a building command, like create table, it goes to a totally different place, the DDL compiler. This isn't just a translator, it's the architect. It takes your blueprint and actually constructs the foundation and the rules of your database, storing all that structural information for later. Okay, so our commands have been translated and they're ready to go. Now they get handed off to the real power players, the components that do all the heavy lifting and, the actual thinking inside the DBMS. First up is the query processor, and this is truly the brains of the whole operation. Yeah, it checks your command for typos, sure, but its most critical job belongs to a subcomponent, the query optimizer. See, there might be a dozen ways to get the data you asked for, but the optimizer's entire purpose is to find the single, fastest, most efficient route. This little genius is the real secret to database speed. It's a total game changer. And then we have what is arguably the most important component of all, the database manager. This thing is a beast. It is the ultimate multitasker. It's the security guard checking if you're even allowed to be here. It's the quality inspector making sure the data follows the rules. It's the traffic controller juggling requests from tons of users at once. And on top of all that, it's the backup expert ready to restore everything if there's a crash. And it's the memory manager smartly deciding what data to keep in super fast RAM for quick access. Seriously, it does it all. But wait, how does the system actually find the data on the physical hard drive? Well, that's where the file manager comes in. Think of it like a warehouse manager who has a perfect map of the entire warehouse. It knows the exact shelf and bin for every single piece of information stored on that disk. And how does every component know all the rules? They look it up in the data dictionary. This is honestly one of my favorite parts. It's so clever. It's a database about the database. It's the official instruction manual, the single source of truth for everything from table structures to user permissions. The entire system is constantly checking in with it. So you're probably thinking, wow, that is a lot of moving parts. And you're right, it is. But all of this complexity exists for one main reason: performance, sheer unadulterated speed. Let me show you exactly what I mean with a quick, dramatic example. Okay, picture this. We have a table with 1 million student records. We need to find just one person by name, but we don't have an index. This means the database has absolutely no choice but to start at record number 1, then read record number 2, then 3, all the way to 1 million. The result? 10 seconds. In the world of computing, that is an absolute eternity. Your user is gone, they've already closed the tab and are complaining on social media. It's a disaster. But what happens if we use that machinery we were just talking about? Remember that DDL building command? We run it just once to create an index on the name column. It's kind of like creating a super fast alphabetized reference in the back of a textbook. And the result? Boom, 0.1 seconds, 100 times faster. That is the power of the query optimizer using an index. And that is why this whole beautiful, complex machine exists. All right, so now that we've met the whole crew, let's put it all together. Let's follow one simple request on its epic journey right through the heart of the system.
So here's the journey. Step 1, the DML precompiler translates our query. Step 2, the query processor checks it and, crucially, optimizes the plan. Step 3, the database manager makes sure we have permission. Steps 4 and 5, the file manager finds the data on disk, and the buffer manager zips it into fast memory. And finally, step 6, the command runs, the data is filtered, and the result is sent all the way back to you. It's like this perfectly choreographed high-speed dance.
So that's the whirlwind tour of what's inside the box. But let's zoom out for a second. How do people actually set these powerful systems up in the real world? Well, way back in the day, everything was on one big centralized computer. It was simple, but it had a huge problem. If that one machine went down, everybody was offline. Today, pretty much everyone uses the client-server model. Your phone or laptop is the client. It sends a request over the internet to a super powerful, secure server that does all the heavy lifting. This is how basically every modern app works.
Okay, one final piece of the puzzle. We've seen the software and the architecture. But how do we decide to actually structure the data itself? Well, that's the job of something called the data model.
And this table gives you a great overview. The earliest models were really rigid, kind of like a family tree. But for the last, 50 years or so, the relational model, just organizing data in simple tables with rows and columns, has been the undisputed king. It's the industry standard. But now, we're seeing these super flexible NoSQL models gaining a ton of ground, especially for handling massive amounts of messy, unstructured big data.
All right, let's wrap this up with the key things you gotta remember. A DBMS isn't just one program. It's a whole team of specialists working together. The query optimizer is the absolute hero when it comes to speed. The database manager is the tireless guardian of your data. We live in a client-server world that is, for now at least, dominated by the good old relational model. And that leaves us with a really fascinating question for the future, doesn't it? The simple, structured table has been the bedrock of the digital world for half a century. But as our data gets bigger, messier, and way more connected, will these new, flexible NoSQL models finally be the ones to take the crown? Well, I guess only time will tell.